All right, so earlier we proved the theorem 5.2.2, okay? So the 5.2.2 is 1 plus r plus r to the n equals r to the n plus 1 minus 1 over r minus 1. Let's actually apply that, okay? So here you can see that, well, by the way I read this formula is if this starts with 1, and now this formula says this power is 1 more than the highest power that you see. That's how I easily remember this formula. So actually I would also use this too when I look at that too. So it starts with 1. The common ratio is equal to r. If you verify, the common ratio r is equal to 3. Verify that, okay? You multiply by 3, you get to the next term. So the highest power here, the n is actually equal to k plus 2, okay? So n is k plus 2 in this case. According to this formula, I will have to, the right hand side will be r to the n plus 1, which means 1 more than the k plus 2, right? Which is k plus 3 minus 1 over r minus 1. And my r is 3, so 3 to the k plus 3 minus 1 divided by 3 minus 1, which is 2. So that's my result. Now, if you look at the second one, okay, again, there are multiple ways to do that. I'm going to show you just one way, but I'll also talk through the second way. So the first way is you can think of this formula want you to start with 1. There's no 1. How about you create a 1, right? So you can say 7 plus 1 plus 3 plus 3 squared plus 3 to the 13. And you just isolate 1 from this 8, so that it becomes 7 plus 1. And then this is like 7 plus. Now you can apply the formula to here with n being 13. So 7 plus and 3 to the, add 1 to 13, which is 14 minus 1 over 3 minus 1, and you do the arithmetic. Or alternatively, you can certainly say, I can do it alternatively, okay? So I'm not going to make any change for the 8, but from this group, I can factor out a 3. Let's factor out a 3. So that means you have 3 times 1 plus 3 plus 3 squared plus the very last term will be 3 to the 12th, because 1 is factored out. And now you're going to apply the formula to this one and do the arithmetic. So that's the second approach. Now for this one, I definitely encourage you to pause the video, try, but here's what it is. I'm going to factor out 7 to the 7 cube, and I have 1 plus 7 squared plus the very last one will be 7 to the n plus 1 minus 3, right? And then this is 7 to the n minus 2. So now you can apply the formula, this formula, to this group with n being n minus 2. Okay, so this is these are some examples of using 5.2.2 theorem 5.2.2. I also strongly encourage you to read the book Proving an Equality. I just want this is really a common mistake that I see from students. I see that very frequently, even from mature mathematics majors. So I would encourage you to read that carefully. Hopefully you are able to avoid that kind of mistake.